We're solving problem 11 from the AMC 12B from 2023. What is the maximum area of an isosceles trapezoid that has lengths of leg 1 and one base twice as long as the other? So an isosceles trapezoid, well, what it's basically saying is that we have this trapezoid here, trapezoid, and this is 1 and this is 1. Those are legs of the trapezoid. Now, we know that this length is 2 times this length, so we can set up an equation, call this one x and this one 2x. If we split it up like this, well, to help you better visualize it, we know that now this is x, and each of these respective parts are x over 2, because they are equal. And together, all these form 2x. So, therefore, using the Pythagorean theorem, we find that the height is the square root of 1 minus x fourths. Alright, we have that. Now, we can really make an area formula for this trapezoid. So, that's pretty simple. The area is equal to 1/2 times x plus 2x, the sum of the lengths, times the square root of 1 minus x squared over 4. Oh, shoot, that's x squared. X squared over 4. And we can simplify this even more to reduce it to 3/4 x times the square root of 4 minus x squared, and take the square root of that. We now have a formula for the area. And a simple way is they ask to find the max area of a shape, and if you know calculus, this is pretty easy to do. You want to take the derivative of this area function here and then solve for it when the bounds are at 0, and then we want a positive area because a shape can't have a negative area in our physical world, and then substitute that value back in. So we take the derivative. So we take dA over dx is equal to 3/4 of the square root of 4 minus x squared minus 3x over 4 times 2x over 2 times the square root of 4 minus x squared. That is our whole area expression. And now we can simplify this area expression. The derivative of a with respect to x is equal to 6 minus 3x squared over 2. Now all we have to do is set this equal to 0, and then, so basically, when we set the derivative of this function to 0, we can find the bounds of the function labeled on a graph. There's usually a positive and negative solution, and we want the positive solution. So, long story short, when you set this equal to 0, you find that x is equal to positive or negative 2, square root of 2. So we want to plug the positive part of the square root of 2 into this whole equation to get our area is equal to 3/2 when you fully simplify it, our answer.